Step 3 for the previous problem, propagation constant. So it is given by gamma is equal to j omega mu sigma plus j omega epsilon. So we substitute all the values here. So this is the answer for gamma. But we have gamma is equal to alpha plus j beta. So alpha is equal to 3.97 Nm per meter. Next is step 4. Step 4 is we denote maximum communication depth by Z. Now for adequate reception, required signal strength is 10 microvolt per meter. So signal strength is equal to e raised to minus az. Therefore 10 into 10 raised to minus 6 is equal to 7.4. So it is e raised to minus 397 Z is equal to 1.35 into 10 raised to minus 6. Now we take the log, so it is minus 3.97 Z is equal to 1.35 into 10 raised to minus 6. So the answer for Z is 3.4 meter. Now the next problem, uniform plane wave. Uniform plane wave of 200 megahertz traveling in a free space is incident normally on large block of material having is equal to 4, mu r is equal to 9, sigma is equal to 0. Then calculate reflection and transmission coefficient. Calculate reflection and transmission coefficient. Here medium 1 is free space, so it is equal to 377 ohm, and for medium 2 formula is this. So it is equal to 4 pi into 10 raised to minus 7 into 9, 8.85 into 10 raised to minus 12 into 4. So this value is 565.10. Now in terms of E bar, we can write TR is equal to 565.10 minus 377 divided by 565.10 plus 377. So this value is 0.1996 retransmitted two into 565.10 divided by 5.10 plus 377, and its answer is 1.996. Next, in terms of H bar, so TR is equal to minus N2 divided by plus N2. So it is 377 minus 565.10 divided by 377 plus 5.10. Its answer is minus 0.199. Next is TT is equal to 2N1 by, so we substitute these values, 2 into 377 divided by, and its value is 0.8003. Next problem, determine amplitudes of reflected and transmitted fields. Determine the amplitude of reflected and transmitted field at the interface of two regions if E1 is 1.5 mV per meter in region for which epsilon R1 is 8.5, mu R1 is 1, and sigma is 0, and region 2 is free space. So here region 2 is free space. Here region 2 is free space. Therefore, it is equal to 377 ohm. Now for region 1, it is equal to mu 0 mu R1 by epsilon 0 epsilon R1. So we substitute these values and we get 4 pi into 10 raised to minus 7 into 1 divided by 8.85 into 10 raised to minus 12 into 8.5. So value for the intrinsic impedance is 129.22 ohm. Next is reflection coefficient. So TR is equal to ET by EI, that is equal to, now we substitute values here, minus 129.22 divided by 377 plus 29.22, and its answer is 0.4895. So ER is equal to EI into 4895, and it is 1.5 into 0.4895. So ER value is 7342 millivolt per meter. Next, transmission coefficient. This is reflection coefficient. Next is transmission. And it is T is equal to ET by EI. So it is 2 we substitute values here. It is into 377 and 129.22 plus 377, so its value is 1.4895. Now ET is equal to EI into 1.4895. The value of EI is 1.5 millivolts, so we substitute it and we get 2.22341 meter. Now next part is we have HR is equal to minus ER by, so it is minus 0.7 3.422. So the answer for the HR is minus 5.68 microampere per meter, and values for the HT. Now we substitute all these values. So next problem, find the transmission coefficient for 10 volt per meter plane wave of frequency 3 MHz incident from the free space, medium 1 normal to the surface of the material, medium 2 having epsilon r, mu r and sigma values are given. So here so it is 377 So for medium 2, sigma is not 0 and it is 10 raised to 3 given. Now for conducting medium, it is equal to J omega mu 0 mu r sigma plus epsilon 0. Now what is omega? It is 2 pi f, so it is 2 pi f is 3 into 10 raised to 6. So we substitute all the values. It is J 2 pi 3 into 10 raised to 6 into 4 pi into 1 divided by 10 raised to 3 J. So by solving we get the values J 2 3 Now we have to convert these values into angular form. So this is 0.02369 angle 89.99 degree. So it is 0.1539 44.99 degree. So in the form of J, the answer is this. Next, the transmission coefficient. Transmission coefficient formula is T is equal to, it is N1 by, so we substitute the values here. Double 8 plus J 0.1088 divided by N1 is 377. It is 1088 plus J. So it is 0.2176 plus J. So the answer for the transmission coefficient is 5.77 into 10 raised to minus 4 plus 5.77 into 10 raised to minus 4. Next problem. Traveling E bar and H bar waves. in free space are normally incident on the interface with a perfect dielectric for which epsilon r is given, it is 3. Calculate ratio of peak magnitude of incident, reflected and transmitted E bar and H bar waves at the interface. So solution is, for perfect dielectric, mu r value is 1 and this intrinsic impedance is 377 and it is calculated by using this formula. It is epsilon 0 epsilon r. So it is 10 to the minus 7 into 1 divided by 8.85 into 10 raised to minus 12 into 3. So value for this intrinsic impedance is 217.5. Now we have ER by EI is equal to, now we have to find these values. 217.5 so the answer for this is minus 0.2683. Now for a transmitted ET by EI, it is answer for this is 0.7317. Next is it is 0.2683 and HT by HI is, so it is 2 into 377 plus 217.5, it is 1.2683. These are the values for magnitude of incident and reflected and transmitted values of E bar and H bar.